Now, let's imagine testing our null hypothesis. So based on our graph, we can ask what proportion of 6s would make us doubt that null hypothesis, or H naught. So we can imagine if we rolled no 6s or 46s, we'd be pretty surprised. We want to put a number on that level of surprise. Now when we test this, we want to ask how likely is it to have gotten these data, or more extreme, given that the null hypothesis were true. Now note this is a conditional probability statement. So based on this distribution, how likely is it to get various numbers here? This is called a p-value, and we'll explain more about that in a moment. What we're asking is how much probability is in the tails. So if we draw a line somewhere around here, how much area is under the curve further away than that? So let's use our specific example of 26s and 100 rolls and ask how likely it is for that to occur. So what we need to calculate is a z-score. All these things are coming back together now as we bring in pieces from the various parts of the course up until now. So our z-score is going to ask how many standard deviations or standard errors away from the mean are we. So we're going to take our actual observed data, 0.2, and subtract our null hypothesis, 1 in 6. We're going to divide all of that by the standard error that we calculated on the last page. Now note, if you're doing this for a new example, you'll have to calculate that standard error separately. So this z-score gives us 0.894. So 0.20 minus 1/6 divided by 0.073. We're about 1 standard deviation away from the mean. Okay? We can see that here if we draw a line up from 0.2. Now we want to know how likely is it to have gotten a z-score of 0.894 or bigger. So for this, like with all of these normal distribution questions, we're going to go to StatCrunch. So if we go Stat, Calculators, Normal, we're going to leave the standard normal. It's our mean of 0, standard deviation for 1. So this means that this x is a z-score. Now we want is greater than 0.894. We click compute. We see that we get a value of 0.815. So this area in the red is about 1/5, or 18.5% of the area under the curve. Now this is pretty likely. This means that 18.55% of the time, or almost 1 time in 5 that we roll 100 dice, we expect to get at least 26s. The null seems pretty likely to generate a value at that point, so we go ahead and we say we don't have any reason to suspect the null isn't real. The null isn't true. And on the next page, we're going to explore this a little bit more thoroughly.